Welcome to Lesson 3.2, Day 1, Solving Systems by Substitution. The objective for this lesson is to solve systems of equations algebraically using substitution. We'll use elimination in the next lesson. Today, we're focusing just on the technique called substitution. So, what is this substitution technique? Well, the name kind of speaks for itself. We're going to make a substitution. We're going to replace a variable with an expression, and that's going to allow us to solve. So here are the steps to this process. So we got our system of two equations with two variables. We're going to solve using substitution. Step one is to take one of those equations and solve for one of the variables. And sometimes it'll be kind of clear which equation we should solve and for which variable, because the algebra steps will be easier. And I think we'll have a couple examples of that in our examples today. So once we solve for that variable, then we can make our substitution. Whatever that variable equals, we can substitute that into the other equation. And that's going to whittle it down from two equations with two variables down to one equation with one variable. So once we've done that, we can do step 3, which is to solve for that remaining variable. And let's say we get x equals 2. We're going to then take that and plug it back into one of those equations to solve for y then. So we get our one solution and we use that to get our other solution as well. So let's apply that technique to this system of equations right here. 4x plus 3y equals 10 and x plus 2y equals 10. We have to start by picking one of these equations and one of the variables to solve for, to isolate. And looking at all of the variables, I've got 1, 2, 3, 4 different variables to choose from. I feel like this one's going to be the easiest to solve for because there's no coefficient in front. I won't have to divide by anything, which could potentially lead to fractions and stuff like that. So I'm going to take this equation right here, and I'm going to solve it for x by subtracting 2y from both sides. So now x equals 10 minus 2y. So what I'm going to do then, if I know that x equals 10 minus 2y, I'm going to take 10 minus 2y and plug it in for x right there. So using that equation on the top now, I start out with a 4, and then for x, I'm plugging in everything that x equals, which is 10 minus 2y. Then we have a plus 3y equals 10. I just took that top equation and made that substitution right there. So now we just have one variable, y, to solve for. And I'm going to distribute the 4 to start that process. So 40 minus 8y plus 3y equals 10. Okay, and now I can combine like terms. I got a negative 8y plus 3y, giving me a negative 5y. Subtract 40 from both sides and divide by negative 5, I get an answer for y of 6. Okay? Now, if I just stop right there and put a box around that and call it done, I'm going to get not full credit here because I have not solved for the other variable. I don't know what x equals yet. So what I got to do now is I got to take y equals 6 and plug that in somewhere. Well, I got options for where I plug 6 in for y. I could plug it in here. I could plug it in here. Or what's probably going to be easiest is if I plug it in right there, because I can do some maybe mental math in that situation. So now I know that y equals 6, x equals 10 minus 2 times 6. I just plug 6 in for y in that red equation. So x equals 10 minus 12, so x equals negative 2. So for final answer here, we have x equals negative 2 and y equals 6 using that substitution method. All right, so there's our first example using substitution all taken care of. Just to reiterate, I could have started by solving for y, and provided I did all the algebra correctly, I still would have got the same answer. I just thought it was easiest to solve for x in that bottom equation because it did not have a coefficient. And that's usually how I make my decision in regards to which variable is going to be easiest to solve for. So let's look at one more example here, and I would encourage you to maybe pause the video and try this one, and then start playing the video again to see if you've done it correctly. So to solve this system using substitution, I first have to pick one of the variables to solve for. And again, I have 4 options. I can solve for m, I can solve for n. But looking at this, I'm going to pick the one that does not have a coefficient, so I don't have to do any division. So I'm going to solve for n in that top equation there. I can do that by adding that 2m over because it is a negative 2m to begin with. So I would add it to move it over. So n equals 6 plus 2m. And now that I know that n equals 6 plus 2m, I'm going to make a substitution in that other equation. Okay, I'm going to take 6 plus 2m and replace that for n over there. So I've got negative 7m plus 6. And then for n, I'm plugging in everything that n equals and finishing off my equation with that equals 1. Now I do my distribution. In order to start solving for m, I'm going to have a plus 36 plus 12m right here. I can combine like terms. It looks like I have 5m plus 36 equaling 1. I subtract 36 from both sides and divide by 5 on both sides. Looks like m equals negative 7. That's half of our answer. To figure out what n equals, I have to take negative 7 and plug it in for m somewhere. I can plug it into this equation. I can plug it into this equation. Or what I prefer to do is plug it in this equation because I already have n isolated. So that's what I'm going to do. N equals 6 plus 2, and then we figured out that m is negative 7. Well, that's 6 minus 14, which would be negative 8. So final answer in purple here now, we have m equals negative 7. We have n equals negative 8. When you're solving systems of equations, you could, in theory, like write your answer as an ordered pair, like answer, comma, answer. And I do that usually when I have x and y as my two variables, because I know that x like comes first and y comes second traditionally, right? But here I wouldn't necessarily know. I mean, alphabetically, m comes first, right? And then n, l, m, n, o, p, yeah. But traditionally, if it's x and y, I'll write it as an ordered pair, potentially. But when it's not, I usually just write it out as m equals and n equals. But just know, if you see answers written as an ordered pair, it is technically okay to do that. I usually just reserve that for when I have x and y as my two variables. So we have now done 2 examples of solving using substitution, and that is our objective for this lesson today, solving systems using substitution. In our next lesson, we'll learn a different method for that, but substitution was the key for today. So this was 3.2, day 1. Thank you for watching.